So we have, spreading acts of kindness. So she decided on day 1 she'd pay for 2 random people. So on just day 0, I guess we can call it, initial amount, there's only her. But then on day 2, she bought for 2 people. So there's 2 total. So on day 2, those 2 people, right? Those 2 people are going to use X's, are going to buy, right? So on day 2, how many are there total? So we got 4 total on day 2. And if we continue this, how many will we have on day 3? We get 2, 4, 6, 8 total. Right, and then one more time. What do you think it'll be? 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 2, 1, 2. Each of those just represents drink. Fill all those out. Count them all up. Days, that's 16 copies total. So the question is, how can we figure this out, or how can we figure out day 5 and day 6 and so on, but without having to show the work, so to speak, and draw out these diagrams? How can that be done? So where's the pattern in these numbers? What's the pattern in these numbers? Multiplied by 2. So I mean, day 1 is basically 2, right? Day 2 is 2 times 2. Day 3 is 2 times 2 times 2, and so on. So yeah, you can see the pattern. As soon as you recognize the pattern, that's when you don't have to go through all this work. And what you guys know this as would be, well, 2 to the 2 is 2 to the 2nd power. This would be 2 to the 3rd power, right? And 2 to the 4th power. We want to know what's going on day 4, and we know it's doubling every day. Yeah, doubling would be times 2, so 2 to the 4th power. And we can even work our way backwards and say, well, this would be on day 1 would be 2 to the 1 power, since it hasn't doubled yet, it's just 2, right? And we can even go back this way and say, well, that's 2 to the 0 power, because 2 to the 0 would be equal to 1. So yes, there are patterns here, and exponential patterns. Here. So there is a pattern there when you're doubling, and you can figure out what the next day will be without having to actually draw out all this out. So that's what the idea is, kind of learn the pattern and then give an equation from it, and it'll tell us somewhere in the equation, okay, like here the number of people is e to the n in the exponential function. Okay, so we're going to use for our equation p to the n. Going to be, as we just figured out, 2 to the n power. So whatever day we're on, we just plug that in, we'll get for how many copies for that day. Exponential function. Okay. So just remember a base of 2. A base of 2 is like doubling. So review a little bit. We have a base, we have an exponent. So the base is the growth factor. So how much is it grown by? It's doubling every day, so it makes sense that our base here is going to be a 2. But that's the growth factor. And usually the exponent is how many it could be years, months, you know, it could be any time. So, and there's going to be another number we're going to come across, and that's going to be the initial amount. And you notice on some of your problems, there's a number in front of the base that was being multiplied by, and that's the initial amount. Now, in this particular problem, how many people did we start off with? Back up here. How many people we start off with? Yeah, we just had 1. So technically, the initial amount could be 1, and we could write 1 times, but it's not really necessary to write 1 times anything. It's just that anything. So that's why we don't have it here. Yeah, you really have 3 different numbers. Really, it's just the base and the initial amount we're trying to figure out. That'll be the format for forming all equations in exponential form. All right, so let's just use this. All right, and say we want to know what happened on day 6. So plug in 6 to this, 2 to the 6th power. And so I mentioned it's nice to have a calculator handy where you can just type in 2 to the 6th. Right, you get an answer. You're not, spending any more time than you have to on arithmetic. If not, you can always just write it out, right? 2 times 2 times 2 times 2. Now, I recommend that instead of doing 2 times 2 is 4, times 2 is 8, times 2 is 16, times, do it like that. Kind of group them together. So this 2 times 2 times 2 is 8, and this 2 times 2 times 2 is 8. So 8 times 8 is 64, and it might be a little faster to, do exponents that way as opposed to 1 at a time. Do a couple groups and then multiply those 2 together. So 64, and since it's a word problem, let's put on some units here. 64 copies. So with word problems, always look at the question and say, what's the total number of copies? So your answer, 64 copies. So it's very clear. And that's the basis for really making all the equations. If you know how many you're starting with, you know what your growth factor is, how much it's increasing by or growing by, right, then you can really form any equation with just figuring out those 2 values. All right, so let's just do a few more. The next one is very similar. So Jeremiah, Stacy, David want to spread X of kindness again. 3 of them decide on day 1 that they randomly pay 2 strangers in In-N-Out meals. For In-N-Out meals, they agreed to do the same act of kindness. 2 people the next day. So the number of people, P of n, is an exponential function because it's basically doubling. So what would this look like? And once again, we can do this probably for the last time. I think you guys will catch on the pattern after this. But person 1 here will have to buy 2 meals. Right? Person 2 will have to buy 2 meals. Person 3 will buy 2 meals. Person 4 will buy 2 meals. Person 5 is going to buy 2 meals. And that person will buy 2 meals. So altogether, how many meals would be on the second day? Count them up. Yeah. 2, 4, 6, 8, 10, and 12. 12 total. And we can continue this. Like that person will buy 2 more. That person will buy 2 more. Right? But at some point, you're going to be like, wait a minute. Hopefully I see the pattern. I don't really need to draw out all this work to figure out and count up how many are left. There should be some pattern in those numbers, involving exponents. And just if I figure that part out, I won't have to do this any longer. Okay. But at all else fails, this does work. Okay, so that's what I'm showing you, that if you're not quite sure how to make the equation when you come across it on your quiz tomorrow, you can always just, draw it out and count how many. Right? It works. It's a little arduous, but it does work. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 on day 3.
Now we know it's doubling, right? So we know the growth factor just talked about over here, our base. We know it's doubling, so it's going to be a base of 2. That doesn't change. So this is still like 2 to the 1, 2 to the 2, 2 to the 3, right? And this will be 2 to the 4 since it's day 4. But these numbers don't match up, right? And why is that? What's missing? Yeah, the initial value. Before, yet on number 1, the initial value, well, we started off with 1 person, so it was just 1. But our initial value here, how many people are doing this? 3. So you can see, as soon as we multiply everything by 3, oh, okay. So that does work out. 2 to the second is 4. 4 times 3 is 12. 2 to the 1 is 2. 2 times 3 is 6. So we can keep on going and say, well, 2 to the 4 is what? 16. 16 times 3 is 48, right? And we can predict we can predict how many there are going to be without actually going through and say, okay, these 2 and these 2 and those 2, and trying to figure out that way. We can use the pattern instead. So that's what it's all about, is trying to find that. And again, technically here we could do, it's technically 3 to the 0 power. 2 times 2 to the 0 power. So that's 3 times 1, which is 3. So it works both ways. So there's our pattern right there, right? Powers of 2, we just had an initial value on this particular problem of 3. Okay, so we can write our function. I think it said P of n again. Yeah, P of n. Okay, so we can use P of n. So P of n equals this time 3. Now, just to avoid confusion, you can do either times 2 to the n, like that. You can use the times or the parentheses or both like that, just to make it clear, what you're supposed to do. Remember that when you're doing order of operations, you have to figure out the exponent first, and then on here you would multiply by 3. So if they ask us to do what P of 6 is, so we plug in 6. Nope, 2 to the 6. Right. We've got to remember that order of operations says do the exponent, so you have to do what 2 to the 6th is first. Then second, you have to multiply by 3. So don't multiply 2 and 3 and get 6 and do 6 to the 6th power. That would be against the order of operations. So we have to do 3 times, and what's 2 to the 6th? 64. All right. And 3 times 64. Go off to the side and do this. Okay, 2, carry the 1. Yeah, 192. And what's our units here? Okay. In and out meals, or you can just say meals. It's fine. Right, like the last one, we didn't say 64 Starbucks, but 64 coffees. And we're not actually buying Starbucks stores. We're not buying in and out stores. We're buying the meals. Okay. So use the right units. So not too bad, right? As long as we know what we're growing by and what we're starting with, we can come up with an exponential equation and predict. I can go up to 50. Technically this kept on going for 50 days. We could figure it out, and we wouldn't have to draw a giant diagram. So not too bad, right? Let's keep on going. See yet another slight difference here. Okay. So what if we had a tournament that began with 32 teams, and after each round, it's half the teams are eliminated. So we're not doubling anymore. We're going down. We're taking half. Right? So after these 2 teams, right, there's only 1. From each of those 2 teams. There's only 1 that goes to the next round. You might see this coming up in about a month. Then the half, we have March Madness starting. That's the college basketball tournament. Starts off with 64 teams. Right? 64 teams in the final bracket. So I'll just do those right here. Right, so each of the first games, you get one winner from every, two teams play, and then you get one winner, and then those two teams play, and then you get one winner, right? And that process just keeps going until you have one team left over, the champion. Right, so again, I'm showing you both we're doing the long way, just so in case at one point you do get, let's see, let me put this over here. And yeah, those two. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, just in case you get stuck, you could always just write it out, although somewhat difficult. So we have 16 teams, and then we have 1, 2, 3, 8 teams. And you can see, yeah, it's going down by half, right? Taking half each time. So what's going to be the next one? Starting here, round 1, there's 16 teams. Round 2, there's 8 teams. Round 3, there's going to be 4 teams, half as much, right? Round 4, there's going to be half as many. 2 teams, right? That's a championship game. Usually in basketball, they call this when there's 16 teams left, they call it the Sweet 16. And then they call it the Elite 8. And then the Final 4 teams left, and then the championship game. And then the last round, those 2 teams play each other, and you have a champion. 1 team left over. Right. So how can we draw an equation from this? Well, we know what's the growth factor here? We can see it. Right? Half. Growing by half, which technically you're not growing, right? It's getting smaller. It's getting smaller. So our growth factor is a half, right? Growth factor is half for each of these. But how many teams are we starting with? 32. So we got to have that initial starting point. What are we taking half of? Oh yeah, we got to take half of 32, and then take half of that number, half that number. So you got to have whatever you're starting with. You got to have that in the front, so we know what we're actually taking half of, right? So it makes sense, right? We got the first round, right? Will be equal to 1. So 1/2 to the 1 power would just be 1/2. 1/2 of 32 is 16. Right? So it all works out. So just keep that pattern in mind. And again, we could do it over here and say, oh, this is 32 1/2 to the 0, since we haven't started. And since it's to the 0 power, it equals 1. And 32 times 1 equals 32. So that works. Okay. You could also look at this as a negative exponent, because technically 1/2, right? That's 2 to the negative 1. So you see that when we're shrinking, or where the numbers are getting fewer and fewer, it's a negative exponent, right? But it's still a positive number. We can't have negative 32 teams, or we can't get negative 16 teams, right? It wouldn't make sense. Even though it's going down, they're still positive numbers. So that's why negative exponents, another reason negative exponents are positive numbers. It wouldn't make sense. You can't have negatives Broncos, negative Bronco team. There's no such thing. It just doesn't, make any logical sense. So we can do this and say, let's write our equation here and get, I think it's a t to the end up there, so we can say number of teams left over is going to be 32, right, to start off with, and we're going to take a half after each round. Okay? And n is like the number of rounds you're playing. And we already kind of figured out above, just by pattern, after 5 rounds, right, after the 5th round, how many you should have the champion. You have only 1 left over. So let's do that algebraically just to show it works both ways. Okay, so let's plug in 5. Make sure it works. So we'll have 32 times 1/2 to the 5th power. And what is 1/2 to the 5th power? Okay, so if you want to, go off to the side. Okay, do that. I'll do the top. It's 1. And what's 2 times 2 times 2 times 2? Yeah, you get 32, which makes sense, right? 32 times 1 over 32 equals 1. 1/10. And this would be, yeah, 1/10. Which, since it's only one team left over, that's the champion team. Okay. So initial, how many we're starting with and what it's growing by. Notice how if it's going down, the number's going down, it's a positive fraction. It's technically a negative exponent, but it's a positive fraction. So no negative numbers here. You can't have a negative team. All right, let's do the one more, and then we'll be good to go. All right, so height of a bouncing ball. Okay, one ball is dropped, and the first bounce reaches is 8 feet, so we're going to drop some ball. All right, it's going to bounce, bounce, and each successive bounce is smaller than the one before it. All right, and they're saying the first bounce reaches, we'll call this bounce, I'll call them down here, bounce 1, bounce 2, 3, 4, 5. So we can still set up any diagram for basically any problem that we need. And we know that the first bounce, they say, is 8 feet, right? So that ball must have been dropped from pretty high if it's bouncing 8 feet back into the air after you drop it. All right, the next one I think it says was 6 feet tall, so it goes down a little bit. Now at this point you might be thinking, okay, it's going down by 2 feet every bounce, right? So the next one should be 4, but they tell us above it's 4.5. So this is not linear, it's not just going down by 2 feet, it's decreasing exponentially. Okay, so the question is, well, how much is a bounce here and how much is a bounce here? When will it finally, how many bounces will it take for it to stop bouncing? How long will it take for it to stop bouncing altogether? And so we kind of see that pattern, right? Now, we don't know this initial height. Right? We don't know where it's actually starting, but we do know on day 1 it is starting at 8. Right? But how much is it going down? What's that factor it's going down by? So in the previous problems, right, they told us, oh yeah, it's very clear, it's half. Right? It's going down by half. But what if they don't tell you? How can we figure out, just by looking at these numbers, how much it's going down by, what the factor is if it's not given to you? Right? If I give you this 3, 6, 12, 24, 48, right? How can you figure out, oh, that's a factor of 2? Right? So just simple as this. Take any two numbers that are right next to each other, okay, and then divide them. So 48 divided by 24 equals 2. Or we could have used these two numbers. 24 over 12 equals 2. This is somewhat like a slope where you have to, find the change of y, change it, put y's on top and x on the bottom, things like that. It's something like that. You just have to do successive days and say, the next day over this day or something like that. And you can see, well, here's what the factor is, right? I can get 2, which is the same factor that we already knew in this case. So it's important on this last one to figure out that even if they don't give you what that growth factor is, you can still calculate it yourself. You can calculate that growth yourself. So going to here, we can see that we have 6 over 8. So what is that? What's that growth factor? How much does it go down by, or what did it increase by 3/4? By 3/4. And if we did 4.5, right, divided by 6, what would that equal? 3/4. The same thing. So you can use, just like when you're finding slope, you can use any 2 points, you get the same answer. Same thing here at exponential. You can use any 2 and you get the same ratio. Okay, you get the same answer. As long as you have it in the right order, okay, it works. So that's what happened with our, now we have our growth rate, right? So we can say it's 3/4 to the n. And our initial we're going to use, since we don't know the initial at the very, very beginning, we can use our first height here. Which is 8. That's all we know. Now, does this work? If I plug in 1, do I get an answer of 8? So let's just see what happens. I plug in 1, what do I get? I get 8 times 3/4. Do you think that's going to equal 8? No, that's going to equal the next one. That's going to equal 6. So you can see how I want to plug in 1 and get 8. I want to plug in 2 and get 6, but I'm plugging in 1 and it's giving me this. It's giving me one more than I need. I need this to be over here. I need this answer to be 1 less. Instead of being 2, I need it to be 1. So we're going to do a little trick here and just put a little -1 on there. And what's going to happen is that when I plug in 1, it's going to be 1 minus 1, which will give us 8 times 1, which gives us 8. So everything was off by 1 when I just used 8, because they didn't really tell us, right, what was this initial starting value. Like I told us before, we started with 32 teams. We started with, 1 person. We started with 3 people. This one didn't really tell us where we started. It only told us after 1 bounce, right? So it's kind of like if I told you, after 1 round it's 16, right? Could you work backwards and figure out we started with 32? So that's what happened. That's why we have to move everything over 1. Everything's off by 1. So I put a little -1 on there to adjust for that. Okay, so if they don't give us the starting value, right? That's the almost starting value. Right? Almost starting value, okay? That's why I added on this -1. So if they give us not at the very beginning, but what happened after the first one, that's why I put a -1 on there to adjust for that. We only have the value after the first bounce, not the very beginning. Okay, so a little slight correction, and that takes care of it all. So we can put in to the 4th power to figure out the 4th bounce, right? I think they say this is h to the n, height. Yeah, that makes sense. Height at 4 bounces, and we can figure that out. Again, here's where the calculator will come in handy. Oh yes, 4 minus 1, sorry. This we have a -1. So we have to figure out, well, it's 3 times 3 times 3, and that's 27. 4 times 4 times 4, that's 64. So now you just have to do what's 8 times 27 over 64. Okay, 8 goes into 64 8 times. So we have 27 divided by 8. Okay, what is that? Approximately. Looks like it's a decimal. Because 8 goes into 24 3 times, right? So calculator time. Let's do 27 divided by 8. We'll get 3.375. And 3.375 what? What are the units here? Yeah, we're dealing with feet, right? Everywhere we see it was talking about feet, so let's make sure we're clear that this is not inches or centimeters, but this is feet. And there we go. We could also figure that out just by continuing this. Right, so if you weren't quite sure, you could just take 4.5 and multiply it by 3/4, and you'll get your 3.375. Right? We can multiply that by 3/4, and we can get what happens on the fifth bounce. We can keep on going and do this the long way, and it should be the same answer. But the question is, of course, well, what if they want to know what happens, after 20? Well, we're not going to just manually crank out times 3/4 times 3/4 times 3/4. That's what this is for. It tells us how many times to multiply wherever we started by 3/4. A little bit faster. Okay, so there is your examples for all of your problems here. Okay, so that should help you out nicely through everything. All else fails, you can always show the work. And you do have a quiz tomorrow. So be ready for that.